Alright, you ready for this? This is the holy grail of programming, and it's called threading. What threading allows you to do is it allows you to take a normal process and then put it onto a different thread that will allow your program to either run faster or not be interrupted while running. Now I have 4 different methods of threading here, and plus a regular one for reference. So let me show you first the code that I've got going here. This is, I'm defining 10 bitmaps. I'm starting a stopwatch too. Now if I haven't used stopwatch, what it does is it allows you to read in milliseconds or even processor ticks how long something takes to do. So anyways, when I click the first button, which is the for button, it just does a for I equals 0 to amount minus 1. And then pick set, and it calls this pick set function here. And what that is, it defines first, that the 10 amount of bitmaps are new bitmaps, 640 by 480, and then goes through each pixel and defines them as blue using set pixel. Now, set pixel is a slow process. If you do it one by one, it's pretty dumb slow. So, anyways. After we call that, we then put the amount of time it took into label1.text. So just as a reference, let me hit play and hit 4. Alright, now this is label 1 here, and 10 pictures takes it 4.9-ish seconds. I can hit that again and it'll tell me a new time. So this is our base of reference here, is for how long something takes. So 5 seconds. Okay, now the second piece of code, now let's leave that up and running, is parallel for. And what parallel for does is it's real simple, real easy. Instead of calling for I equals 0 to amount -1 pick set, and then I, what we're doing, because I gets transferred through that as the integer of the current pitch that we're handling. So when you call the parallel for, which is threading.task.parallel.for, the 0, which is equivalent to this guy, 0, to the amount -1, which equals to this guy, and then address of pick set. So it's calling this directly right here, and that automatically puts in an integer into the first byval or byref, what have you. So it calls that and dumps that into label 2 for the amount of time of the stopwatch. Notice stopwatch is reset here. So let's click that. Click here. Now the other one took 5 seconds. This one's going to take 2 seconds. That is a heck of an improvement, isn't it? Click that guy again. It varies sometimes, because what this does is instead of calling everything in order, which can be interrupted or doesn't use all processors, it calls them all the time. Now here is a task manager, and actually running quite high. I didn't expect that. Of course I wasn't running screen capture before either. If I click 4 here, now that's going to run, and it only boosts up maybe about 10%. You can see the graphs rise. Now it's done. In fact, let me boost the speed up a little higher. So high. Okay, so I'm averaging about 40, and when I click that, I went up to 60. When I hit parallel 4, though, check this out. It bumps right up to 100 using all processors, and is done quick. You saw that? That was pretty sweet. Now the next piece I'm going to show you is background worker. Now background worker you actually define when you're making your project. So I'm going to stop my program real quick. Now background worker is right here. You double click that and you add that to your program, and it adds it right there. What background worker does is it basically causes your program to work in the background. Now notice if I hit 4 and try to drag this around, I can't. Can't really see my hand moving, but I try to drag it up. There it goes. Okay, fine. Click this guy, try to drag it, nothing, can't do it. Okay, there we are, finally. Now background worker, what it allows it to do is it puts it on a thread behind asynchronous happenings. It'll run this stuff in the background. So really what I'm going to do here is when button 3 is clicked, restart my stopwatch, run the background worker asynchronously, and that calls the background worker do work event, which you can get by double clicking right here on the background worker. And then I just simply, like the for statement, call for the 10 pick sets to be done. And then on the background worker run worker completed means it's done. I update the millisecond timer. Now to get the worker run completed, you have to go here to your object thing here, run worker, and then you have do work, work completed, progress change, what have you. So that's how you would access that event. Alright, now this guy, even though he is just as slow, I can move him around. He is just as slow as the for statement, even actually a little bit more. I assume it's because of these extra events. So click, and I can move him around. This is good if you want to run something in the background, not disturb your main process. Alright, now I have two more to do, thread pool and a regular thread. Thread pool, these actually I cannot, because they make their own thread that don't really report back to the main thread. I can't just modify an object. I'll show you what happens, but first I'll explain this. Thread pool is a lot like the background worker in the effect that it just puts something in the background, and it's a single line. It's simple to use. So threading.threadpool q user work item address of call one thread, which is right here. So I just restart my timer, call my pixet, and then I use a message box to tell me how long it took. So click that, and see, I can move stuff around, and the time label isn't going to change. However, there it is right there, 5 seconds. So, okay, that was pretty easy to do. Just one line, it calls a sub. Pretty easy. Now, the next piece is the thread. Now, thread's a little more difficult. I've only ever had to use this once because it required a certain apartment state, which I'm not entirely sure what that means, to be honest with you. But restart my timer, and I use T, which I define up here at the very top as T as threading.thread. It's a thread. That's all there is to it. So T equals a new threading.thread address of call thread 2. There it is. T is background, false, which I think that would like pause the program. However, I set it and it doesn't stop the program at all. Like, see, if I click it here, I can still move the program around. So I'm not sure what background does. Anyways, set apartment state. There's only two states you can really have. It says STA and MTA for single thread apartment and multi-thread apartment. And even though you would think multi-thread apartment would go faster, it doesn't, because you just saw there it only popped up with the same 5 seconds that the regular for statement had. So this is really just an extra time thing here that you would only use this if your program specifically requested an STA or MTA, and then you start the thread after that, and then that calls thread 2. So I call this, and then I throw a message box. So it's pretty simple. Now here's the thing I want to show you with thread pool and thread. If I say, well, why message box? Let's just put it into its appropriate label. So I'm going to stop my program and say label 5.text equals stopwatch.elapsed milliseconds. Nice and simple. Alright, so I click the button. It's going to run its thread. 5 seconds are going to pass, and 5 seconds pass. There we are. We got an issue here. Cross-threader operation not valid. Control 5 access from a thread other than the thread it was created on. That's because the thread that label 5 is working off of is the main thread of the design. This is its own thread right here. If you call a separate thread and you try to access something, like an object if you will, off this label 5 or a push button or a picture box, it's just not going to have it because they were two separate things. So what you always want to do when you're accessing different threads is only modify really objects like the pics I have here, which are bitmaps that aren't necessarily related to the front of this here. If I wanted to say adjust 10 pictures, then I would just make 10 pictures like this, and at the end of my thread being completed, I would then say now put these in. But really, thread, I couldn't find a decent usable method to say this is completed. And the same with thread pool too. I mean, I guess I could set a bit and have a timer always monitoring that bit, but that just seems unnecessary. Run background worker seems to be good if I wanted to do something that's in the background. I mean, thread pool is simpler, but background worker is a lot easier to work with. So, okay, enough of this. I understand. Undo, 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 undo. There we are. Okay. So now there's one more thing I wanted to hit on before I end this, and that was, well, the Parallel 4. You say, wow, Parallel 4, that's awesome. It took so little time and it was so quick at doing it in a 100% processor. That's what I'm looking for. Well, there's one thing you got to know. Notice here in my time waster that I'm going for, let's see here, set pixel. I'm using 2 more 4s here for the width and the height. Now, why don't I just use parallel 4s for these guys as well? That's because you really can't set parallel 4s to a single object. This has to be like an array of objects or something with sub-objects, because this right here is an array of bitmaps. The reason is that I've tried this before. Like I tried saying, you know, for each pixel of a single picture, set it to blue. Well, the problem is that it tried to set to blue, but the object was already in use. So each object that you use has to be its own object. So a picture or a label or a piece of text, it can't be, you know, each pixel in a label or each character in a line. So yeah, just so that's understood. So obviously the clear winner here is Parallel 4 because it's so quick and so nice as opposed to the regular 4. And you can actually probably even nest a Parallel 4 into a background worker and then have background tons of information being used. The only thing I wanted to recommend you keep in mind is that if you run a very long Parallel 4, it's going to peak your CPU pretty highly. You know, if I say bump my thing from 10 to 30, there we are, pictures, and I hit Parallel 4, it's going to drop it up there. You know, Windows 7 is pretty good. I can still move stuff around. I got all my things here. You know, it took 6 seconds, so that's pretty good. But you got to keep in mind how much I'm feeling my fan right now, my laptop, and it's pretty baking, I gotta say. And so what my point I'm getting at is that you got to be careful that you're not overtaxing your computer with this, because this is the, as I said, the golden, what do they call it? Shoot. Anyways, this is the cream of the crop here of processing stuff, is the Parallel 4, which allows you to use your computer to its max capacity. Just make sure that you're not going to kill your computer with it. That's the only thing I'm trying to get at. So anyways, have fun with that.